Hi everyone, I'm Abby, Field Application Engineer of Nuvoton. Welcome to the M031 Level 1 training. Today, I'm going to introduce the sample code of timer. First of all, you can download the M031 BSP from Open Nuvoton, which is the GitHub of Nuvoton, and unzip the file. Then, you can find the Level 1 training folder under Sample Code folder. All the Level 1 training sample codes are under Level 1 training folder. The path of timer sample code is under BSP, sample code, Level 1 training, Level 1 timer control, Keil, this folder. The project file, Level 1 timer control, is the sample code of timer. In this demo, we will show two operation modes among timer's four operation modes. They are periodic mode and toggle mode. You can also see how they work more clearly while the on and off of LED lights controlled by the timer. You can see the mapping between the pins and LED lights in the table on the right-hand side. For timer 0, it could use 3 pins, PC3, PC4, and PC5, which are mapping to LED blue light, LED red light, and LED green light. For timer 1, it will use PB14 as its output pin. In periodic mode, we use timer 0 to trigger interrupts periodically. You can write code in the handler function to identify what to do when an interrupt is triggered. In our sample code, we change the pin status of PC3 to toggle the LED blue light once per second. In toggle mode, we use the toggle out function of timer 1 to toggle the pin status of PB14. We change the pin status of PB14 to make the according LED light toggle twice per second. Before the demo, we would like to show you the source codes of our sample code. We will go through the sample code via Keil IDE to let you know better about it. Let's open the Keil project file of timer. In main.c file, the main function defines what we will do in this sample code. Before getting timers to work, there are some initializations to do. First of all, we call system_init function to initialize the clocks of system and peripherals. Before calling system_init function, you have to unlock some registers in order to set clocks. After setting, you have to lock the registers again to avoid modification. In system_init function, there are two things to do for timer. One is to enable the clocks of timer 0 and timer 1. The other is to set the clock source of timer 0 and timer 1. In this sample code, we use HXT, which is external high-speed crystal oscillator, as the clock source of both timer 0 and timer 1. After system_init, we call UR0init function to initialize UR0 for outputting log message. After initializing, below log messages could be output through UR0. Since we will use LED lights to show the operation of timer, we have to initialize LED as well. In LED_init function, we set PC3, PC4, and PC5 as GPIO function, and then set the 3 pins as GPIO output mode. Afterwards, set default value of all 3 pins as off. Now, we call timer_init function to initialize timer 0 and timer 1. Timer_open function is used to set the mode and frequency of a timer. For timer 0, it is set to periodic mode with frequency 1 Hz, which means once per second. Since timer 0 is periodic mode, we have to call timer_enable_interrupt function to enable the interrupt. If it is enabled, an interrupt will be triggered when time is up. In addition, there should be a corresponding function to handle the interrupt after the interrupt is triggered. Therefore, you need to call NVIC enable IRQ function to enable this mechanism. The step calling NVIC enable IRQ function is very important. If you do this step, an interrupt will be handled by a default function. If you miss this step, there will be no handling when an interrupt is triggered. For timer 1, it is set to toggle mode with frequency 2 Hz, which means twice per second. Under toggle mode, there won't be interrupts triggered. When time is up, it will toggle the signal instead. Therefore, we have to set an output pin for toggle mode to output the toggled signals. In this example, we use PB14 as the output pin of timer 1. All the initialization has been done. We can then start timer 0 and timer 1 by calling timer start function. Afterwards, timer 0 and timer 1 start to count by their setting. We have mentioned that timer 0 will trigger an interrupt when time is up. There will be a default function to handle the interrupt. In the sample code, the default function for handling interrupt is timer 0 IRQ handler function. In timer 0 IRQ handler function, it will check if the flag of interrupt triggered is raised. If it is raised, toggle the corresponding LED light. In this sample code, we toggle the LED blue light by timer 0. The hardware we are going to use in this demo includes two boards. One is the evaluation board, NuMicro M032SE. The other is Level 1 training board. The position of PB14 LED light is on NuMicro M032SE. The position of RGB LED 1 light is on Level 1 training board. The two boards could be connected together. We will connect the evaluation board with the computer when we are doing demo. Before connecting the evaluation board to the computer, we have to turn on the virtual COM port on the evaluation board to enable the UR transmission. The way to turn it on is to switch number 1 and number 2 of the virtual COM port to on. Afterwards, connecting the evaluation board and the computer via USB cable. If the connection is successful, you will see the virtual COM port status from the device manager of the computer. After connecting the evaluation board with the computer, we're going to show you how to do programming. In this demo, we'll use Keil IDE, for example, to show how to build image and program. In Keil, you may click the Rebuild button to compile the codes and generate image. If the compile is successful, you may click the Load button to program image into our microcontroller on the evaluation board. You may also refer to the video, The Best MCU Beginner Course, Lead Your Way to the Nuvoton Development Platform, for more detailed information, such as evaluation board introduction or steps of IDE download and programming. After the programming is done, connect the board to the computer. Turn on the terminal, set the UR COM port and baud rate, and connect. Then press the Reset button on the evaluation board to restart. You will see the log messages from the terminal. At the same time, you will also see that the blue LED light toggles once per second in periodic mode, and the red LED light corresponding to the output pin PB14 toggles every 0.5 seconds. This is an example application of our timer function with LED light. Above is the introduction and demo of Level 1 training timer sample code. Thanks for watching. Please do not hesitate to contact us if you have questions. You may subscribe our channel for more information.